Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 9G. Myself, Priyanshi Goyal, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid. The physical event was held yesterday in Bangkok, Thailand, and the physical event was held day before yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today, and it was held yesterday on 5th and 6th of April 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I'll raise a gentle reminder. I request everyone to kindly adhere to the timeline so that we do not end up delaying the session. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chairs for this session, Dr. K. Silvamani and Dr. Archana Chaudhary. Dr. K. Silvamani is an associate professor in the Department of Computer Science and Engineering at Anna University, Chennai, India. His expertise spans distributed computing, computer security and reliability, and artificial intelligence. With a strong research background, he is committed to advancing innovations in secure and intelligent computing systems through his academic and scholarly contributions. Thank you so much for joining us, sir. I invite you to deliver the welcome remark and set the tone for the session. Do we have you here with us, sir? You're on mute. Can you hear me, sir? I think there might be a technical error. All right, we'll be moving forward for now. Okay, sir is here. So your audio is not like you're not audible. No, you're not audible. Maybe you can try rejoining or join by phone if that might solve the audio glitch.
Audible now? Is it audible now?
Yes, sir. Yes, sir. Now your audio is audible.
Yes, ma'am. Yes.
Yes, sir. Hello.
Yes, ma'am.
Yes, sir. I was just saying that I request you to kindly deliver the welcome remark and set the tone for the session.
It's not clear for me. I think some network problem is there.
Okay, I'll move forward then.
Yes, ma'am. Yes, ma'am.
All right. We have another chair for this session, Dr. Archana Chaudhary. Dr. Archana Chaudhary is an assistant professor at Vishwakarma Institute of Technology, Pune, India. She has over 20 years of experience, including 4 years and more than 15 years in academia. She has published several research papers in international journals and conferences and is an IEEE member. Her research interests include signal and image processing, Internet of Things, control systems, and artificial intelligence and machine learning. I request Dr. Archana Chaudhary, ma'am, to kindly deliver the welcome remark and set the tone for this session. Ma'am, do we have you here with us?
Yes, Priyanshi, thank you for the introduction. I welcome all the participants for the 9th International Conference on Information and Communication Technology for Intelligent Systems. And I also would like to say that by sharing their research work, the other participants will also gain some insights on how to conduct research further. So I welcome them, and I also congratulate them for their presentations. And now we can go ahead with the session.
Thank you so much, ma'am. Thank you so much. Now, without further ado, let's start the session for the day.
Audible now, but is it clear?
Yes, sir, you're audible.
Yeah. Yes.
All right. I'll start the session. I would like, sorry. Okay. I would like to call the first presenter for the day, Tuan Dat Singh, to kindly present his paper titled A Natural Language Interface for Querying a Vietnamese Historical and Cultural Tourism Knowledge Base. Do we have you here with us, sir?
Yes, I'm here. Hello, everyone.
Hi. We'll just stop presenting. Yes, you can share your screen.
Okay. Okay, can you see my screen now?
Yes, your screen is visible. Can you please put it in presenter mode?
Okay.
Yes, you may start.
Okay. Hello, everyone. My name is Dat, and I and my colleague is from Hanoi University of Science and Technology, Vietnam. And today, I'm very happy to be here with you. And I will present about my research. It is a research for tourism in Vietnam. We will build a natural language interface that can query the knowledge base of Vietnam control tourism. And this is the outline of the presentation. I will start with the introduction first. Okay, the tourism now contribute a lot for Vietnam economy sector. And with the trend of digitalized transformation, it's very important to transform this domain, this tourism domain, into digital format. However, at present, there's a few of research focus on two aspects, historical aspect and cultural aspect of Vietnam tourism. So that's why in this research, we try to focus on two main objectives. The first objective you can see here is to develop an ontology-based knowledge base. This means we use semantic web technology to develop the knowledge base. And as I said, our scope focus on Vietnamese historical and cultural tourism. We focus on 6 main entities, including historical figures, historical sites, historical events, cultural festival, administrative divisions, and dynasties. For the second objectives, we try to design a cost-efficient QA system. I want to emphasize that our objective is to develop the cost-efficient system. The goal is enable end users to explore tourism sites in Vietnam and learn about Vietnam culture and history via natural language queries, so they can ask questions in natural language and receive the answer. And with these two main objectives of the research, in the next two sections, I will introduce to you how we can address these two objectives. For the first objectives, we have to build the knowledge-based. And because this approach use semantic web technology, so for the first step, we have to develop the ontology. The ontology development is our scope of this presentation. So I will show you a very basic information about the ontology. So there are a lot of class and property that connect those class, but you can see here we have 6 main classes which are 6 types of core entity I mentioned before. Their festival, for example, and historic event. And of course, we have many connections between those class. Okay, after developing the ontology, for the next step, we have to populate the ontology data. And we identify 2 kinds of data source. For the first, we use structure source from Wikidata and DBpedia. For those sources, they already provide us with the SPARQL endpoint to collect information. And we also collect data from unstructured source like a website here, a website from Vietnam, a very popular website. And for this, we must use web scraping technique. And then we follow several steps to extract data from those sources. We have to identify entities, and we have to standardize the format because the data from different sources come with the heterogeneous format. And some data has conflicts, so we have to resolve conflict by prioritize important source like DBpedia. And then we, of course, have to maintain provenance records. We also have to link entity. And for the final result, we have unified dataset for ontology population. And based on this, based on the ontology here, we can develop the knowledge base. So after the first objective complete, we now move to the second objective of this research. We have to build a tourism QA system. Of course, there are many approaches for this objective, but in this research, we try to use some cost-efficient solution. So we decide to choose RASA. RASA is an open source and machine learning based framework. Its training is very simple. We just define story and scenarios and provide it to RASA, and that's done. And RASA integrates an open source natural language understanding component for intent classification and entity extraction. Okay, so we decide to choose RASA, and our methodology is very different from other research. Normally for RASA, we have to train the intent data by ourselves. But in this research, we, based on the knowledge base, we try to automatically generate the intent training data set. So there's no manual work here. We reuse the knowledge base before and generate the intent training data set. And then when we receive some query, some natural language query from end user, then we convert the query into SPARQL query, and we query the knowledge base and return the answer to users. Okay, that's the idea. And now let's see how can we generate automatically the intent training data set. We define 4 question types only. The first type question is to find something with single condition. For example, the end user might ask us which festival honors Trần Hưng Đạo. And the second type question is to find something with multiple conditions. So it's similar to the previous one, but now we have multiple conditions, like which festival honors Trần Quốc Tảng and is held in Quảng Ninh. The third type question is to ask specific information about some specific entity. For example, user might ask, where is Trần Thái Công resting? And the final type question is to introduce some specific entity, like end user may ask, tell me about Ninh Bình. Okay, and the algorithm here will take the input as the ontology based knowledge, and the output is the intent training question for us. So to do this, we perform 3 main steps. First, we navigate the whole ontology to extract tuples. And then based on those tuples, we generate affirmative sentence. And finally, we have to convert those affirmative sentence into question using diet classifier syntax, which is a syntax in Rasa to generate the training data set. And in this algorithm, we define only 3 main entities: the object, class, and predicate. Of course, we have to recognize other basic kind of entity like number and time. Okay, let's take some example. For example, from ontology, we can get the affirmative sentence like Hung Temple Festival is held at Phú Thọ. So the question could be, which festival is held at Phú Thọ? And then we generate the diet classifier syntax question for Rasa like this. So you see, it's similar to the question here, but for each entity, we have to define specific property like this festival is a kind of class, and this is the full UI of the class in the ontology. So similarly, to be held is a predicate entity, and here is the full UI of this property. Okay, and other example, we have we have 2 affirmative sentence like this. So we can combine these 2 affirmative sentence into a single question like this, and we similarly generate the diet classifier syntax question. Okay, that's how can we generate the intent training dataset for Rasa. And now we have to handle the user from question. For each kind of question, we have to identify the entities.
Hi, this is a gentle reminder.
Okay,
Kindly
and
tap
okay. So for this question, Rasa will allow us to identify entity, and then we can generate the SPARQL query like this. Okay, and with similar mechanism, we can address more complex queries like this. We identify different entities and generate the SPARQL query. Okay, and we have do the experiment with our approach, and we generate 170 questions. And here is the result. We have 4 metrics with 170 questions. The correct answer is 148, and incorrect answer is 22. And the rate of correct answer is approximately 88%. Okay, so for the conclusion, we successfully complete 2 objectives. The first one is build the knowledge base, and the second one is build the QA tourism system. And for the next step, all of us already know about the LLM chain, where large language model can easily understand the user question and can have the ability to reason to answer. But this approach, even it is powerful, but it is not code efficient as our approach. But for the future step, we try to combine our approach with the large language model to improve it. Okay, that's all for my presentation. Thank you a lot. And now I welcome the question.
Thank you, Lal. Are there any questions?
No questions from my side.
All right. Sir, are there any questions?
Yes. Very good presentation. I have one question. What is the data set that you are using for training?
Sorry,
What is the data set that you use for your intent training?
Okay. As I said, first we First, for the first objective, we have to build the knowledge base, and then we generate the training data sets automatically from the knowledge base.
Yeah, what is the name of the data set?
The name of the data set,
Yeah.
the data set built by ourselves. So I do not have a name yet.
Okay. What is the size?
The
Size of your data set?
Okay, it's 10 megabyte.
10 megabyte.
Yeah.
Okay. Okay, because you have shown the sample sizes around 200 questions. The training data set size should be more, right? It should be in terms of GB or something like that. Okay.
Yeah, because we identify 4 question types only, so the problem will be simpler. With 10
Okay.
megabyte, still provide quite good result already.
Okay. Okay. Good. Okay. Thank you. Thank you.
Thank you, sir. Thank you, Raj. Can you please stop presenting?
Yeah,
Thank you so much.
yeah. Thank you, everybody.
Yes. Moving forward, I would like to invite Mohammed Taslim Arif to kindly present his paper titled AxiShield, IoT and AI-powered accident detection and notification system for intelligent transportation. Do we have you here with us, Taslim?
Yes, I am here. Can you hear me?
Yes, just a second. Yes, please.
Okay, can I share my screen?
Yes. Please share your screen.
Is my screen visible?
Just a second. Yes, it's visible. You may start.
Thank you. I am Mohammad Taslim Arif. Today I am presenting my paper, AxiShield, IoT and AI-powered accident detection and notification system for intelligent transportation. Along with me, my co-authors are Abu Salam Muhammad Musa, MD Mashur Rahman, Nurjan Nipan, Fatimatul Johra, all are from Bangladesh, and we all are from Gazipur Digital University. First of all, I want to focus the problem. Road accidents are the leading cause of death for ages 5 to 29, and in Bangladesh alone, about 35,000 deaths occurred from almost 32,000 accidents between 2019 to June 2024. By this road accident, we can see that almost 3% of GDP in most countries causing major economic burdens. Also, we see that by the research of National Highway Traffic System Administration shows that reducing emergency response time by just 1 minute could save up to 10,000 lives annually in the United States. By focusing on this, road accidents, which causes fatalities, injuries, and economic losses, we proposed an innovative IoT and AI-based accident alert system that can revolutionize road safety by leveraging cutting-edge technologies to detect, predict, and respond to accidents promptly and effectively. Our AxiShield compromises 3 interconnected modules. First one is accident alert system, which employs a sensor called accelerometer, which can detect the accident, then GPS, GSM module, and also a buzzer to detect impacts, trigger alerts, and share location data. Also, the another module is accident image detection system. By confirm that the accident is highly affected, so that we use a CNN model and flag server to analyze images captured by Raspberry Pi camera and classify them as a accident or non-accident scenes. After that, we have a mobile application for monitoring a smart car, which in our research, we only use as DST11 sensor and ESP32 microcontroller to provide real-time temperature, humidity. In future, we will propose that the engine status will be monitoring by this system and enabling remote control of car features through a mobile app. So first of all, I will discuss about our feature accident alert system. To do this, we use accelerometer sensor that detects sudden impacts exceeding a predetermined threshold. After detecting the threshold value, it automatically sound a buzzer for 20 seconds alerting the driver and nearby individual. After that, there comes GSM and GPS module. By GSM module, a pre-programmed phone number is dialed to inform emergency services such as nearby police station or hospital or relatives, and also a text messages will be sent by GPS module to by providing the accident location to the concerned parties, enable them to reach the accident site promptly. The another one is accident image detection system. To do this, we use Raspberry Pi camera, which can capture images of the surrounding environment. After that, this image will be sent to the server, flag servers, and there a CNN model will be trained, and it can detect the image as the accident or non-accident. Then the system outputs a classification results indicating whether the image depicts an accident or not. The another one is smart car monitoring system. To do this, we use DST11 sensor, which provides real-time temperature and humidity readings accessible through the mobile app. We built a mobile app. Then the mobile app also allows users to control car features such as lights remotely. In future, this is only for conceptual basis. In future, we will want to apply this feature to monitoring the engine status, such as the system will be used to monitor engine parameters and notify the users if any abnormalities are detected. So here is the prototype or implementation of our research with just all hardware here. Then this is the system workflow. We power on the system, then it on all the sensor and actuator. If the threshold value processed by the accelerometer sensor, it will on the buzzer for 20 seconds. Then it will scan by the camera. If the accident is really happened, it will send GPS and text messages by location, and also a predefined send a call by the predefined phone number. So this is the system architecture, which I already mentioned. ADXL345 accelerometer sensor is used to detect the accident. Then it will send GPS and GSM location and also a call to the predefined phone number. So here is the output of our project. If the accident is detected, it will the sound is not audible due to I am using a headphone. After that, it will start and buzzer, then it will send a phone call. Then it will send a message by sending the exact location of that accident. Then comes accident image detection. I already mentioned we use Raspberry Pi and Pi camera to detect the images. Here is the output. We can capture the images by Raspberry Pi camera. Then this is the flag server where a dataset, publicly available CCTV footage dataset, which contains only 1,000 images, because we cannot find large scale image dataset based on this accident image. We have to use that dataset. In future, we will try to find out, or we will manually created the dataset, because accident normally happens every time. So we train that dataset using CNN model, and we get 95% average accuracy. Also, we have the smart car monitoring system app. We build this app from our site. It show the temperature, humidity value real time in our application, and also we can control light for the transportation or smart car from this mobile application. Here is the output, how we can use that mobile application. So the system benefits are we build this project for the enhancing the road safety, prompt notification of emergency services and concerned parties for rapid response, accurate location sharing, real-time monitoring of vehicle status, and for the increased driver awareness. We can use this application for personal vehicles to enhance individual safety and convenience. Also, we can use this for commercial vehicles to improve flight management, also for public transportation. Also, we can build autonomous vehicles to enhance safety during testing and deployment using these features. In future, we have to improvement our CNN model because the data set is only contains small images, a small number of images. In future, we will also add multiple advanced sensor for vehicle status monitoring. Here we showed only DST sensor for conceptual basis. In future, when we do this, we will use advanced sensor to monitor engine status. Also, we'll develop a cloud-based platform for real-time data processing and analysis. Also, in future, exploration of machine learning techniques for predictive accident analysis. So we also compare some related works. In those works, we see that they only detect accident by sensor or only image. We compare, we adjust both sensor and image detection process so that the false alarm cannot be accessed. So as a conclusion, we say that Axis Shield can revolutionize road safety by combining IT, machine learning, and mobile technology to address accident prevention and response effectively. It can provide a comprehensive solution for accident detection, alert monitoring, prevention, and response tailored to various vehicle types and transportation systems. Here are the reference. Thank you, everyone. Is there any question?
Thank you, Taslim. Are there any questions?
Yeah.
Yes, sir.
What is CNN?
Convolution neural network.
You
A deep learning.
do you have any specific reason for choosing this particular algorithm?
Because the data set is too small, we basically use this CNN model. We have to use others models, but the data set is small and we cannot find out another large scale data set for the accident images. So we use just this model. In future, we will find out large scale data set and we will use more advanced deep learning model.
Okay, that's all. My turn. That's my point.
Thank you, sir.
Thank you, sir. Ma'am, are there any questions?
Yeah. So the scholar has said that they have trained it on certain data set. So what
Yes.
data set have they used for this training?
Accident. Can you see my screen, ma'am?
Okay. Yeah.
Yes, the data set.
Public data set.
Yes, ma'am.
Okay. Yeah. Thank you.
Thank you, ma'am.
Thank you so much, Taslim.
Thank you, everyone.
Moving forward, I would like to invite M. Sherlyn Jennifer to kindly present her paper titled Advancing OFDM Systems with Deep Learning and SCR Decomposition. Do we have you here with us, Sherlyn? Are any of the team members present? All right, since no one is responding, we'll be moving forward. Right, I request Tripti Gunjal to kindly present her paper titled Analysis of the Technological Developments in Airport Baggage Handling Systems, a review. Do we have you here with us, Tripti? Are any of the team members present? Since no one is responding, we'll be moving forward. Sorry. Yes. I request Kumari Jayashree Devi to kindly present her paper titled Automated International Phonetic Alphabet, IPA, Representation for Assamese Speech. Do we have you here with us, ma'am? Are any of the team members present? I think no one is there. We'll be taking it forward. I request Abhishek Chaudhary to kindly present his paper titled Comparative Analysis of ECC and Blowfish Algorithms for Cryptographic Security. Do we have you here with us, Abhishek?
Yes, yes, I'm here.
All right, I'll stop presenting so that you can share your screen.
Is my screen visible?
Yes, your screen is visible. Can you please put it on slideshow mode?
Yes. So, good morning, afternoon, and evening to all one and all presenter. My name is Abhishek Chaudhary, and today I'll be giving you a presentation on the topic comparative analysis of ECC and blowfish algorithms for cryptographic security. Moving on to the contents. So I will be delivering from the problem definition to the implementation to the comparative analysis and finally to the conclusion of the research paper. Moving on to the problem definition. In the era of the escalating data security demands, selecting an appropriate cryptographic algorithm is essential to ensure both a robust protection and resource efficiency. So this study of the ECC and the ECC, namely elliptic curve cryptography and blowfish encryption, is focusing on their security strengths, computational efficiency, and cost effectiveness to determine their suitability across the various application environments, including mobile devices, IoT, high-speed data processing scenarios. Moving on to the motivation of why selecting this topic. So, as we know, as the digital interaction and the data volume increase, ensuring secure and efficient encryption is paramount. With a growing variety of devices and application from resource-limited IoT system to high-throughput data networks, selecting an optimal cryptographic algorithm becomes a crucial task. Whether to use ECC in a particular task or use Blowfish in a particular task or any other different algorithms, I have selected ECC and Blowfish because they are not that much studied in depth, irrespective of their security performance, cost effectiveness for the diverse environments. The aim is to conduct a comparative analysis of ECC and Blowfish encryption to identify the most suitable algorithm for various sectors and computational and security needs. So the goal is to assess the security strengths, their weaknesses, their performance, and cost effectiveness and suitability in different application scenarios. Moving on to the objective, to evaluate and compare the security robustness, to identify and document practical use cases of ECC and Blowfish, highlighting their main scenarios, what the algorithm is, and ensuring informed decision making for encryption needs across diverse applications. Also, to analyze and compare the computational efficiency and resource requirements of ECC and Blowfish, accessing the suitability for different environments such as IoT, mobile devices, and high-speed data systems. So the study will main focus on the in-depth comparative analysis of both the encryption and decryption algorithm, covering their security, computational performance, and cost effectiveness. So moving on to the literature review, I have taken a few papers of ECC and few papers of Blowfish algorithm. I will tell you the main methodology, the gaps and the key findings, and what happened in the literature review in short. So these are the few 4 to 5 ECC papers. In this, I have just taken, I've gone through the methodology, the key findings. So the method they have used here is, firstly, in the first paper, they have given their comparison with the traditional algorithms. So in the this fifth paper, on the first, you can say, they've compared directly ECC with RSA. I will tell about it in the next few slides. So what it says is that the comparison of ECC with the other traditional algorithms, where it is lacking, where it is good for good, and the key findings here you can see that is ECC provides higher security with smaller key sizes compared to RSA and different algorithm. Then the I will move on to the methodology, like the mobile networks is gone through. Then the only theoretical analysis is done on the basis of the security. Then the basis of the benchmarking in the control environments, and same with the Blowfish papers. So Blowfish papers, the mainly the methodology was in mainly the comparison with the existing technologies, existing the existing technologies, and the key findings are is the increased security. It is fast, it is reliable, it is secure, and it is simple to understand. And these are the few papers which I have done the research, literature review in. There is no as a direct comparison of a Blowfish with the other algorithms with depth, in depth I'm talking. This is the one paper was for the encryption, and so through which we can get to know where blowfish can be used in different sectors in nowadays. So moving on to the common findings of the research paper of all water studies is mainly lack of direct comparative analysis, focusing on the limiting insights into the application specific effectiveness, such as in high volume streaming or mobile encryption. Then the performance in resource constrained environments. Although ECC and Blowfish are accessed for mobile and IoT use, real world comparisons for power consumption, latency, and providing speed remain limited, leaving a gap in understanding which is resource limited settings. Um, then moving on to the data type versatility. Most research focuses on the text and image encryption with limited exploration of ECC and Blowfish. So mainly, I want to convey is that many of the research paper are only basis on, or on only on the basis of either security or on encryption or else on declaration. So collectively I've taken all the security and the other aspects which are telling in further slides. Then the last point is of the common finding is security and multi-layered encryption. While ECC and Blowfish individual security strengths are well documented, there is a little analysis on their combined or layered use within the multi-algorithm architectures where they might enhance overall security. So moving on to the implementation of the algorithm, this is the on the right side which you can see is the elliptic curve. On if we have given a message, then the message is broken into the parts and the curve is created. A line is drawn and the line perfectly cuts maximum. The line can perfectly cut the curve into maximum 3 points, and then we have to choose a point G on the elliptic curve. Then select a random private key. Before starting for implementation, I will tell you about what ECC is. ECC is an asymmetric type of algorithm which uses two keys which I have mentioned here. So first a random key is taken D, and then the public key is calculated with the point multiplication of the D into the point G which we have taken on the elliptic curve. Then moving on to the encryption part, then the sender gets the receiver's public key Q. Then a random integer K is taken. Then there are 2 points which is C1 and C2 which is plotted on the graph of the given elliptic curve. There C1 is calculated by the multiplication of K and G, and M is the message point on the curve which lies on the curve. And then the C1 and C2 is taken and it is given to the receiver side. The receiver uses the private key D to compute the message M. Then after the substitution, the message is obtained. And moving on to the Blowfish algorithm. So Blowfish algorithm uses feature structure. It is a symmetric type of algorithm. And first you can see in the diagram which I have mentioned in the right, the plain text is taken, then it is divided into two subparts, the left and the right part. Then the key expansion takes place. For the key, your input key you can take from 32 to 448 bits. Usually from 32 to 448 bits is taken. Then it is divided into two parts, and the further encryption decryption I will explain. Moving on to the total 18 p array values. So in short, 16 rounds are taken and 18 p array values are taken. 4 S boxes. S boxes mainly substitution boxes, each with 256 entries. Moving on to the encryption part, the plain text is split into the left and the right part. Then you can see for the first round, the XOR is taken from the left part and the XOR of the left part and the P array first is move on to the right side, and then it is XORed again. So this round is continuously till the 16th round, and in the final round, the after you can see swap the L and R. So the at last the left and the right side is swapped, and after total 16 rounds they are swapped again, which is the P17th array and the P18th array, and then we will get the cipher text. Then the same order is this was for the encryption method. Then we will receive the cipher text. After receiving the cipher text, the reverse, the same which I explained right now, is done for the decryption process. So moving on to the main comparative analysis, which I did is first mainly on the security strength. So ECC offers high security with smaller key sizes. For example, if we compare it to RSA, RSA takes 3072 bits of key, whereas ECC takes the same amount, but in a smaller key size. Like for example, 256 is taken for the 3072 RSA bit size. So it makes it more efficient for the mobile and IoT devices. It resists classical attacks via um, elliptic curve discrete logarithmic problem, which may be vulnerable for future quantum attacks. Then the security strength of Blowfish, it provides a strong
This is a
security with
gentle
variable
1 minute reminder.
Okay, thank you. So moving on to the Blowfish security strength, it provides strong security in the key length between 32 to 448 bits, and uh, 64 block size makes it susceptible to certain modern attacks, limiting its applicability. Moving on to the resource use and scalability. So ECC uses smaller keys, and it is useful in the environments like IoT. And Bluefish is known for speed, and it can be used in VPNs. Moving on to the applicability and the real world use cases, ECC is used in secure communication, Bluefish is used in VPNs. And the cost effectiveness is it provides long term savings, and Bluefish is lower cost. And moving on to the preferred algorithm by the sectors. Mobile IoT refers ECC because of its well battery life as a constraint. In data address encryption, Blowfish is used here. In secure communication, ECC is used. In the legacy system, Blowfish is used. In the financial and transaction and digital signatures. Digital signatures on we can do it virtually here. ECC. Moving on to the final results and finding, ECC uses smaller key sizes, providing the same security with less storage and computation. Then Blowfish is fast and efficient. Then Blowfish shows vulnerability to brute force attacks at smaller keys and lacks hardware acceleration support. And alternatives like Twofish and AES can be are better security with high efficiency and are recommended for the future protocols. These are the applications and the advantages you can see. So ECC is high security per bit, resource efficiency, and long-term use. Applications is IoT, mobile, digital signature, and blockchain. And for Blowfish, it is variable key length from 32 to 448, open source. Application is data address encryption, legacy system, image and media encryption. So in conclusion, I would just like to say that both algorithms are good in various different sectors in mobile devices or in IoT. Yet Blowfish continues to find an application in domains requiring both speed and flexibility. And Blowfish has proved efficient enough for numerous practical applications, hence ensuring it remains valid in modern computing. Thank you. These are the references which I've taken. Any questions, sir, ma'am?
Thank you, Abhishek.
Thank
Are
you.
there any questions?
Yeah, yes, I have. Mr. Abhishek,
Yes, sir.
yeah, what is the novelty that you have shown in your work?
I've shown that how ECC and Blowfish, how they mainly differ in the comparative analysis which I've shown in security strength, the resource use and the
Yeah,
scalability.
yeah, I understood. But these are all things which is already available, which is predetermined one, right? So it has been already clearly determined everything, right? It is available in the book, it is available in the net, everything is there. What is the novelty that you have investigated something new and what you have incorporated in this case? Because Blowfish is an encryption algorithm and this ECC is used for security of the keys, right? Exchanging between the sender and the receiver.
Yes, sir.
What is the novelty that you have invented or something you have developed in this work?
Um, I went through all the research paper, and from my side I got to know that ECC is used for only the smaller key sizes, and Blowfish
Yeah,
is known for speed.
that is known for everyone, right? You know the functionality of the ECC, which is smaller size, will provide more security than RSA. It's a simple task. Even this is a simple thing that has been already represented in all the books as well as net. Whenever you just ping on the net, it will be available. Is there any novelty that you have invented or something you have shown relevant to this proposal? That is my question.
No, sir. Sorry, sir. I've just done the comparative analysis in depth by taking the papers of ECC and Blowfish together.
Because my question is, this Blowfish is an encryption algorithm with respect to the same key, right? It's a symmetric.
Yes, sir.
And you're comparing
Yes, sir.
with asymmetric algorithm. That is my question. Why you want to compare the symmetric and asymmetric? If there is any comparison between asymmetric two algorithms, then you can do some. You can say some of things. You're comparing symmetric and asymmetric.
Yes, sir.
That's my question.
Just for the better understanding of what ECC is and what Blowfish is.
Okay, Okay. Okay. Thank you. Thank you.
Thank you, sir. Thank you, Abhishek. Are there any other questions?
No questions from my side.
All right. Thank you, ma'am.
Thank you all for a valuable time.
Right. Moving forward, I would like to invite Francine Claire to kindly present her paper titled Determining the Authenticity of Philippine Civet Coffee Using MQ Sensors and Artificial Neural Network. Do we have you here with us, Francine?
Hi, yes, I'm here.
Hi. Um, yes.
I'll be sharing my screen now.
Yes, please. Your screen is visible. You may start.
Okay, so good day. I am Francine Claire Tiponzalan from Apo University, Philippines, with my co-authors Vianrici V. Santos and Noel B. Vinsangan, here to present our paper entitled Determining the Authenticity of Philippine Civet Coffee Using MQ Sensors and Artificial Neural Network. So a brief introduction. Civet coffee, locally known as cape alamid, is produced from coffee cherries that have passed through the digestive system of an animal called Asian palm civets. The digestion process is believed to enhance the coffee's flavor and aroma by breaking down proteins in the cherries, which leads to civet coffee being considered one of the most expensive coffee types in the world. Due to its unique qualities and rarity, civet coffee is highly sought after and commands premium prices. However, rising demand has led to an increase in counterfeit products, making it crucial to develop reliable methods for distinguishing authentic civet coffee from fake ones. Recent studies have explored how electronic nose technology helps analyze distinct caste markers in food. It is said that the aroma is the most important quality factor in civet coffee. Basing on the previous studies, the researchers found out that there is a lack of research specifically focusing on determining authentic Philippine civet coffee from non-authentic civet coffee. So the objectives of this study are to create a portable electronic nose system using MQ sensors and Raspberry Pi, to use artificial neural network ANN for feature extraction and support vector machine SVM for classification, to differentiate the characteristics between that of a Philippine civet coffee from a non-civet coffee, and to use confusion matrix to evaluate the accuracy of the ENO system. This study primarily benefits the coffee industry in the Philippines by providing a reliable method to distinguish authentic civet coffee from non-authentic civet coffee based on its aroma. Future researchers may also use this study as a reference for further exploration into the classification of Philippine civet coffee using similar techniques with MQ gas sensors. The scope of the study was limited to ground civet coffee found in 3 different regions in the Philippines. Specifically, it focused on ground civet coffee from Kalinga, Eastern Visayas, and South Cotabato, excluding other types of coffee. Figure 1 illustrates the research process for developing an ENO system for civet coffee authentication. The study began by reviewing literature and previous studies to identify gaps and define objectives. This led to the conceptual framework, followed by hardware development using a Raspberry Pi, MQ sensors, and an analog-to-digital converter, and software development for data acquisition and machine learning. The experimental setup involved controlled conditions for data gathering from coffee samples, which was then statistically analyzed, and the results were interpreted to reach a conclusion on the ENO system's effectiveness, potentially leading to refinements in earlier stages. As seen in Figure 2, the ENOS device's primary operator was a Raspberry Pi 4 Model B with 4GB RAM powered by a 5 volts at 3 amperes power supply. The sensors used were MQ2, MQ3, MQ7, and MQ135, selected based on the gases present in the coffee aroma. Coffee samples were placed in an enclosed chamber where the sensors detected the aroma. The sensor sent analog signals to the ADS1115 analog-to-digital converter connected to the Raspberry Pi. The device's 5-inch LCD display then showed the classification, indicating whether the coffee was authentic or not authentic civet coffee. The system flowchart shown in Figure 3 outlines the sequence of operations in the coffee classification process. The procedure begins with setting up the ENO system. Once the system is initialized and the aroma is detected, The process moves to the ANN module. Here, the detected aroma data is pre-processed to ensure it is ready for analysis. The pre-trained ANN model is then loaded and relevant features are extracted from the data. Next, the system proceeds to the SVM module. In this step, the features extracted by the ANN are passed to the pre-trained SVM model. The SVM model then performs the final classification, determining whether the coffee is authentic or non-authentic based on the features. The classification result is displayed on the LCD screen, providing users with information about the authenticity of the Philippine civet coffee being analyzed. Figure 4 illustrates the experimental setup of the ENO system. The trials were conducted in a controlled environment with stable room temperature and humidity to ensure consistent conditions for all samples, minimizing the influence of external factors on the gas sensors and aroma analysis. For each trial, 1 cup of ground coffee was placed in a measuring cup inside the ENO's chamber, which contained 4 MQ sensors. After securing the chamber, data collection began following a stabilization countdown where the sensors detected and recorded the volatile compounds emitted by the coffee. Once data collection was complete, machine learning models classified the coffee as either authentic or non-authentic civet coffee, with the results displayed on the ENO's LCD screen. To prevent cross-contamination, the chamber was ventilated after each trial to remove any residual aromas. The system was then reset for the next trial, ensuring accurate measurements for each subsequent coffee sample. Figure 5 illustrates the sample output of the system. It shows whether the coffee sample is either authentic civet coffee or non-authentic civet coffee. For each trial, the system goes through a countdown to ensure that the sensors went through their heating time. Then, the system starts collecting data depending on the number of rows specified. Afterwards, it displays the coffee's sample type. 5 samples were used for testing. 3 samples were authentic civet coffee samples, which includes Kalinga civet coffee, Palawan civet coffee, and Matutum civet coffee. 2 samples were non-authentic civet coffee samples. A total of 48 trials were done, having 24 trials for authentic civet coffee and 24 trials for non-authentic civet coffee. The confusion matrix shown in Table 1 illustrates the detailed classification results with 22 true positives, correctly classified authentic civet coffee, and 18 true negatives, correctly classified non-authentic civet coffee. The confusion matrix also shows 2 false positives where authentic civet coffee was misclassified as non-authentic, and 6 false negatives where non-authentic civet coffee was misclassified as authentic. The higher number of false negatives suggests the system may be more lenient in identifying authenticity, possibly due to overlapping aroma profiles between authentic and non-authentic civet coffee. The accuracy describes how accurately the system can classify data correctly. The equation used to calculate the accuracy of the system is shown in equation 1. The target accuracy for the confusion matrix was set at 80%. After performing the calculations using the actual results gathered, the researchers determined the model's accuracy to be 83.33%. Overall, this research focused on developing an electronic nose system using MQ sensors for aroma capturing, artificial neural network for feature extraction, and support vector machine for classification. The prototype was able to determine whether a coffee sample was authentic civet coffee or non-authentic civet coffee. With MQ sensors, the aroma was captured inside the coffee chamber, and an analog to digital converter was used to transmit analog signals to digital signals to be processed by the Raspberry Pi 4. The accuracy of the confusion matrix is 83.33%, indicating that the model can reliably determine whether a coffee sample is authentic civet or not. As for the recommendations, future researchers could expand the dataset by incorporating a greater variety of coffee samples, including non-civet coffee from the region where the civet coffee was sourced. To enhance the model's accuracy, the coffee chamber could be redesigned to be smaller and more confined, allowing the sensors to more precisely capture the aroma emitted by the coffee sample. So that is all. Thank you for listening.
Thank you, Franson. Are there any questions?
Yes. Yeah.
Right.
May I know what is the data set that you are using?
We collected the data set ourselves. We gathered 54,000 samples, which
Okay.
are 24,000 samples from authentic and 30,000 samples from non-authentic.
Okay, good. Thank you.
Thank you, sir.
Any other questions, ma'am?
Yeah, so good work, no questions.
Thank you, ma'am. Thank you again, Francis.
Thank you.
Moving forward, I would like to invite Mohammad Ataur Rahman to kindly present his paper titled Exploring the Impact of Software Engineering Concepts on Sustainable Engineering Education. Do we have you here with us, sir?
Yes, I am here.
Okay, just a second. Yes. Can you please present your screen?
Okay. Can you see my screen?
Yes, your screen is visible. Can you put it in slideshow mode?
Okay, all good.
It cannot be seen in slideshow mode.
Now good.
No, sir, I still cannot see it. Can you just press F5? Then that will help.
Okay, I will try again.
Yes.
Now you can see.
Yes, your screen is visible.
Okay, thank you. Hello.
Yes, sir. Yes, sir. Your
Hello.
screen is visible. It's not in slideshow mode. From the button at the bottom, at the
Now.
bottom of the screen. No, at the bottom of the screen near the minus sign.
Okay. I know. Now see.
Yes, sir. Your screen is visible.
Okay. Good.
Yes, sir. Yes, sir. You may start.
Okay. Thank you. Hello. My name is M. Ataur Rahman. My co-author Tawsid Jahin Khan, Sabina Alam, Chitra Bonik, and Mahadi Hassan. All are from Independent University, Bangladesh. This is my presentation outline. Introduction. Software engineering concept affect academic performance. Software engineering concept directly influence student academic performance, guidance area, and improvement. SDM, we use machine learning and specifically SDM get best performance to predict CGPA based on engagement and software engineering perspective. Focus on uh, practical learning using a software tool, applying project management, enhance education outcome, literature review, enhance technical and problem solving skill. Software engineering education help students develop problem solving and technique skill through project and management tool and coding. Innovation education tool, AI tool based and likes activity and development learning system offer personalized learning and improve software testing, outcome-based education using OOB framework and engineering education improve learning outcome and meet international accreditation standard, collaboration learning and challenges, tool like Google for Home and support framework like our learning management system face challenges, student involving and participate activities. Research methodology. Here we can see machine learning approach for software engineering concept and sustainable engineering education. Research methodology start with data collection and pre-processing to fix missing value. After cleaning, the data is ready for analysis. We use different machine learning algorithm and training and testing the model and check performance based on accuracy. Evaluate the model help find the best algorithm of the data and guidance, data drive decision and suggestion. Data collection, we use Google survey for whom there has 21 question. This topic related we say question general information, software engineering tools, AI and simulation, software requirement gathering, project management and engineering, software development methodology, uh, project experience, lab facilities, general coding and problem solving skill and BSc result. We data collection from independent university Bangladesh, we use various question and answer. Question parameter has 1 to 5, like 1 equal not helpful and 5 equal strong helpful. We use collected information from student independent university on the impact of software engineering concept and software engineering subject related student. This is the Gamoho dataset feature and dataset description. Dataset preprocessing. We preprocess data step by step. First, we collect raw data, then checking null value, label encoding, and correlation. Finally, we check normalization, then set dataset for training and testing. Experimental procedure, we collected from total 770 student data from Independent University Bangladesh. This data set is split two parts, training data 70%, testing data 30%. We use evaluate the data set accuracy, mean, absolute error, root square error, and mean square error R square. And we regression model is here random forest decision tree, Gaussian boosting, support vector for regression and X boosting regression. Here we can see his table. This table show performance for each algorithm. Support vector for regression perform best of all other models. We with the highest R square value 0.83 and lowest mean absolute error 0.12 and accuracy here 94.81. The X boosting and random forest regression have accuracy here 98.61%. Decision tree here regression has accuracy of 92.21, and which is 5.2% lower than the base algorithm. The Gaussian boosting algorithm has lower accuracies and difference of 18.84 from support vector for machine regression. Support vector regression perform better because it is handle complex data and strict and right balance and overfitting. Decision key identify factor for CGPA. Looking at the project management tool use, coding practice and confidence help is which affect the student success. Improve teaching method. Understand how to factor and impact CGPA help. Improve the curriculum focusing area project management, AI learning, and handle on coding. Predictive performance and providing support. Using this factor help predict student perform early and offer personalized help and improve academic result. Conclusion: key factor affecting CGPA. Project management software to hold coding practice and confidence play will big role in student academic success. As SDM showing best accuracy, improve education, additional one hand Hands-on learning and AI-based simulation practice project and curriculum can help students do better. Data lab instructor and coding skill also help. Future research and improvement. We plan to the study effect and curriculum changes over time and comparison new AI technique like deep learning and traditional method. It improve student performance, and we try to work big data set. There he has a 770 data set. There is reference. Thank you. Thank you. Any question?
Thank you so much. Are there any questions?
No, ma'am, no questions from my side.
Yes, sir. Okay, no question. Any other questions, ma'am? All right. We'll be moving forward. Thank you, Atul, for your presentation.
Okay, thank you.
Moving forward, I would like to request Perenbanathan Vasanthan to kindly present his paper titled From Followers to Trendsetters, Ability of the Firms to Counter Disruptive Innovations, Business Turbulence, and Emergence Industry Trendsetters. Do we have you here with us, sir?
Yes, I'm there. Am I audible?
Yes, sir, you're audible.
Is there an echo or everything?
No, there's no echo.
Okay. Just give me a moment to bring it down.
Sure, sir. Yes, sir, your screen is visible.
Yeah, just give me a moment to put it on slide mode. Is it in the slide mode now?
Yes, you may start.
Okay. This is primarily review paper. We have used bibliometric review to review the existing papers and to analyze the trend and the future direction. So basically what we have done here in this paper is to take, we have taken two groups of researchers that has happened in the past. One group of research, primarily capturing how a firm can survive a disruptive innovation, an external disruptive innovation, and to become an at least ongoing going concern kind of. And the other part of researchers are talking about how the firm can be an innovator, and it can potentially, bring in disruptive innovations to the industry. So these two groups are, the two groups of these studies are separate, and there is no interlinking. But there has to be a larger, interlinking between these two, because a firm which is already existing and it can, try to survive an external innovation, disruptive innovation, and then it has to move forward, and it has to become, it has to survive, and then it has to move forward to become an industry trendsetter as well. So this is what we are studying in this particular research paper. So moving from, the struggling concern from the disruptive innovations, the external disruptive innovation, to, how it can become an industry trendsetter. So just to understand a bit of background of what is disruptive innovation. Disruptive innovation primarily is talking about how a low-end disruption or a new market disruption can become the mainstream, and then can eventually displace the mainstream player themselves. For example, if we take the mini computers, quite some time back, when it has replaced the mainframe computers of IBM. It is one of the good examples of how the low-end products that are seemingly not meeting the current customer requirements can at one point in time become a mainstream product and can displace the existing player completely. And with respect to new market disruptions, if we see the food delivery apps, those have completely created, at least to a larger extent, a new market segment where probably many customers wouldn't have even looked at buying food from outside, but now they are buying from the restaurants nearby. So these are the kind of, the disruptive innovations which can, eventually create trouble to the existing players. And how the firms can survive the such kind of disruptive innovation is one group of studies that we have found in the existing literature. So this is vast, and we are only capturing some high-level points in this slide. And one of the effective ways that Christensen, suggests to survive the external disruption is to, effectively integrate and reconfigure internal and external competencies. And also, at some point in time, if the organization can bring in the agility, meaning how agile or how quick they can be to an external, a trigger to their survival. And all these things, are called as dynamic capabilities that can make the organization a bit more, responsive, and it can help the organizations survive such an eventuality. And such kind of operational adaptations, which involves the reconfiguration of the internal and external, the competencies and altering the business models, will eventually end up increasing the overall firm performance and would potentially help the firm to, survive such a turbulence caused by the external innovation. And one key nuance that we can look at in this particular setup is, say, multi-supplier approach. For example, a firm is there and it can have multiple suppliers supplying components and products to this particular firm. So such a multi-supplier setup would, most of the time, it helps in the survival mode because of probably the agility that the whole setup can bring in. And part of the risk is also shared by the suppliers. And the next group of studies are, focusing on the innovation, how the firm can be more an innovative firm. And contrasting to the last point that we have seen in the previous slide, here the vertical integration, meaning all the components, whatever is required for a particular product, if it is produced by the same company, it can have a larger control on the quality and overall timelines. And this is what we have seen in many of the recent companies which are extremely innovative. So they try to have a vertical integration. So this is quite contrasting from the previous slide that you can understand. And the transformative business models, increases the adaptation of such innovative technologies, and the new transformative technologies like artificial intelligence, blockchain, and all those, the recent technologies would definitely help the firm to improve the overall performance and the innovativeness. And the senior management strategic orientation, whether they are oriented towards market or whether they are oriented towards the customers, that would help the firm to focus on more on innovation. And the design thinking obviously provides a more structured view of how the innovation can be adapted. And so primarily coming to the focus of this particular study. So this is capturing the transition from how the firm can move from the confined space of the market is being captured by the external innovator and so on, and how it can move up and then move out to become an innovator, and then it can capture the larger market, and it can become bit free with respect to the market dynamics. And in this study, we are trying to address the questions like what are the trends in this particular research area, and what are the growth trends in this particular area, and what are the emerging key concepts from the existing literature from both from these two groups, and what are the future potential research topics and directions. This is what is the objective of this particular study. And for this, we have used a bibliometric analysis. And as we have set the right approach in identifying the existing research area, so we have acquired about 454 papers, and we have primarily used Scopus as a source of research articles. And as part of the purification process, we have excluded all the other document types, keeping only the research articles and reviews to move forward. And then, as with respect to the publication stage, we have excluded all in-work research articles, and then we have included only the finally published research articles, which reduces the numbers to 311. And out of scope, meaning the papers that are not really talking about what we wanted, because we have just used only the keywords. And the keywords has pulled a lot of other papers as well, which are not really talking about or focusing on the particular research area that we are focusing on. So excluding those out of scope papers, we ended up with only 136 papers. And we have used these 136 papers to assess and evaluate and report what are the, and to address our questions and to answer our questions. And for this evaluation,
1 minute reminder.
Yeah, sure. So for this evaluation, we have used Bibliometric and VOS Viewer and BiblioShiny. And these are the research trends, as you can see. Though we see that there is the number of research papers that are getting published in 2025 appears to go down because we have used only until February, and it may not be necessarily that it is going to go down. And these are the emerging themes, three themes that we have identified, and primarily it is talking about artificial intelligence and how these kind of innovative technologies can help the firm to be innovative, and ambidexterity, meaning how the firm can sail on two boats of explorative innovation and exploitative innovation. That is also another theme, and these are the future research topics that we have identified. There are 5 basic topics: AI-driven decision making, and then digital transformations, how it can help, and then the ambidexterity. This is basically talking about the survival, and then firm's ability to counter. This is also survival, and how to foster organization agility and countering the management's firmness. So these are the research topics that we have identified, and there are certain limitations as well, which are listed down here. And primarily, our focus here is to bridge the gaps between these two groups of study, and then understanding the current research and setting a future direction. So this is the objective of this particular study, and these are the references shown in this presentation. And thank you for your attention. And if there are any questions, I'm happy to answer.
Thank you so much, sir. Are there any questions? Any questions?
No, ma'am, good presentation. I have no questions.
Thank you, sir. All right.
Thank you so much.
Thank you so much again, sir.
Yeah.
Moving forward, I would like to invite Prashant Roth to kindly present his paper titled Hybrid Deep Learning Framework for Retinal Disorders Classification using VIT, Efficient Net, and ResNet 50 with risk grading. Do we have you here with us, sir? Are any of the team members present? Since no one is responding, we'll be moving forward. All right. We missed a couple of people earlier. I would just call out the names again. If anyone is present, please let me know. I would like to invite Sherlyn Jennifer to kindly present her paper titled Advancing OFDM Systems with Deep Learning and SCRG Decomposition. Do we have you here with us, Sherlyn? Are any of the team members present? All right. I'll be
She'll join in 5 minutes.
in the next 5 minutes.
Yeah.
Please ask her to join soon. We'll take her
Yeah.
presentation at the end.
Okay, sure.
I would like to invite Tripti Gunjal to kindly present her paper titled Analysis of the Technological Developments in Airport Baggage Handling System, a Review. Do we have you here with us, Tripti? Are any of the team members present? I can see Tripti.
Yeah, am I audible?
Yes, you're audible. Would you
Actually,
like to
there's
present?
some issue with my system. I'm just trying to resolve it. I need some like 10 to 15 minutes. Will that be okay?
I'm not sure. It depends if the other presenter is here.
I'm trying to resolve it.
Right. Please try to resolve it as soon as possible.
Yeah, just give me like maybe if there is someone else, then they can present.
Yes.
Thank you.
All right. The last person would be Jayashree Devi. I would like to invite you to present your paper titled Automated International Phonetic Alphabet, Representation for Assamese Speech. Do we have you here with us, Jayashree?
Yes, ma'am. Am I audible?
Yes, you're audible. Would you like to present?
Yes.
All right. You can share your screen now.
Okay. Can you see the screen, ma'am?
Yes. No, not yet. Yes, your screen is visible. Yes, your presentation is visible. You may start now.
Yes, ma'am. Now, is it all right, ma'am?
Yes, it's visible. Please
Okay.
go ahead.
Thank you. Good afternoon to all. I am Kumari Jayashree Devi from Guwahati University, Guwahati, Assam, India. Thank you, ICTIS, first of all, for giving this opportunity. My co-author and guide is Parishmita Sharma, Department of Information Technology, Guwahati University, Guwahati, Assam, India. My topic is Automated International Phonetic Alphabet Representation for Assamese Speech. Automatic speech recognition or voice recognition is a technology that converts spoken language into written text. The goal of speech recognition system is to accurately transcribe spoken words and phrases into written form. This technology has various applications across different domains, including virtual assistants, transcription services, customer service, language translation, etc. Pronunciation and an alphabet set for local language like Assamese language may not be understood by global community. So for representing Assamese speech into text for global community, we need international phonetic alphabet representation. This project will transcript Assamese speech to IPA. Objective of the project is to develop a system for global users which can directly convert Assamese speech to international phonetic alphabet. Thus, it helps the users to verify correct pronunciation of Assamese language. Assamese speech input through a microphone in real time or can specify an audio file path by the user so that the model can directly convert speech to IPA transcription. The International Phonetic Alphabet is a standardized system for phonetic transcription. IPA symbols corresponding to Assamese vowels and consonants are shown below figure. In the figure, the last row represents the vowel of Assamese alphabet corresponding to their IPS symbols, and above 3 rows shows the consonant of Assamese alphabet with their corresponding IPS symbols. In the project, we have used Web2Vec2 XL SR300M pre-trained multilingual ASR model. For dataset, Assamese speech dataset, almost 2,000 samples for processed into training, validation, and testing set. For fine-tuning the model, 3 steps will be followed: data preparation, tokenization and feature extraction, and fine-tuning of the model. This is the model architecture of Web2Vec2 XLSR model, which was developed by Facebook AI. Unlabeled speech, where unlabeled speech refers to audio recording of spoken language that do not have corresponding transcription. Web2Vec2 leverages self-supervised learning techniques to pre-train on unlabeled speech data. Model fine-tuning for model fine-tuning, several steps will be followed for recognition, translation, and classification. This is the flow diagram for fine-tuning the Web2Vec2 XLSR model. In the first step, we have done data preparation. For this, we have collected Assamese speech data with transcription for training, validation, and testing set. Then convert this Assamese transcription to IPA transcription, and implementing the tokenizer and feature extractor. In second step, data pre-processing was done for normalizing the audio and encode the transcription to label IDs. And then set up the trainer. For that, define the data collator evaluation metrics for character error rate, word error rate, F1 score, etc. And training arguments was set up. And then some hypermeters and set point of the model was also loaded. And then start the trainer. For that, load the data in data batches, compute training and validation loss and metrics. Then evaluation process was done on the test data, and at last deploy the model. Deploy the model in user interface. This is the overview of the dataset. The dataset used in the project is collected from the Common Voice 11.0, a public dataset released by Mozilla Foundation containing Assamese speech audio that was in .mp3 format, where Assamese sentence, age, accent, client ID, etc. was included. But we keep only audio part and sentence column and removed all other in our project as it is not necessary. For data filtering, special characters in the transcriptions are typically not required to comprehend the meaning of a speech signal. Therefore, we remove all the characters that do not contribute to the meaning of the word. Here we can see the sentences with IPS symbols. Data tokenization. For the model, use a tokenizer that is called Web2Vec2 CTC tokenizer that handle tokenization process. For that process, some functions of Web2Vec2 tokenizers are tokenization, decoding, handling CTC, and vocabulary management, where tokenization is the process to convert the target text to sequence of the meaningful tokens. Decoding converts predicted token IDs back into human-readable IPS symbols after the model generates its output. Handling CTC, that manages the alignment between input audio features and target text sequence. Vocabulary management keeps a list of all IPS symbols that could be utilized in the transcription. Next is data pre-processing. Here also some steps have been followed. For that, first of all, we have to extract some features. In our project, for feature extraction, the model requires some parameters like feature size, sampling rate, padding value, normalization, etc. In the project that we have collected the data set, the audio samples was in 48 kilohertz, but the model needed 16 kilohertz of sampling rate only. So we have to resample the data from 48 kilohertz to 16 kilohertz of sampling rate. Experiment and results. In this experiment, different metrics such as F1 score, word error rate, character error rate are calculated. In every step, F1 score is increased and word error rate and character error rate decreased gradually. But it has been found that the character error rate is decreased significantly to 14%. This is the graphical representation for evaluation metrics, CER, EWER, and F1 score. For performance accuracy of the model, as we have got 0.14, that means 14% of character error rate. So accuracy will be 1 minus CER. So 1 minus 0.14, that is 0.86, means 86% of performance accuracy, which is a relatively high accuracy that indicate the model is performing very well, which a majority of predicted IPA characters are correct. Testing model. The model is being tested by creating an user interface where user can either specify an audio file path or record directly in real time. We also have tested the model by using Hugging Face repository, where an audio file was given in real time, which was in Assamese. A fulpa bordhunia. That means in English, means it's that this flower is very beautiful. The transcription of IP transcription of corresponding this audio is shown in the below figure. Now I conclude my project. The project has made significant progress by fine-tuning the CNN-based model to adapt to the unique phonetic characteristics of Assamese, achieving a character error rate of 14%, which translates to an 86% performance accuracy, indicates that the model is capable of generating reasonably accurate transcription at the character level. However, the project also encountered challenges as evidenced by a high word error rate of 96% and an F1 score of 0.03. This means metric highlight areas where model's performance can be further enhanced, especially in terms of word level accuracy and overall reliability in representing spoken Assamese into international phonetic transcription. For overcoming these limitations in future, we can expand our dataset so that we can include diverse regional accents and tonal variations. And so we can refine the model using advanced techniques like transfer learning and phoneme modeling. So that's all. Thank you. Now open to the question.
Thank you, Jayashree. Are there any questions?
Yes.
Yes, sir.
Ms. Jayashree, I have one question.
Yes, sir.
You told that your model will take an input as an audio file
Yes,
as
sir.
well as real-time data, right? Real-time voice.
Yes, sir.
Will the accuracy be same for both the cases?
Yes, sir. At character level, the accuracy is same.
Is it?
Yes, sir. At character level, the accuracy, we have got accuracy, same accuracy.
Okay. Thank you.
Thank you, sir.
Thank you, sir. Thank you, Jayashree. Are there any other questions?
No questions. I had some issue with the mic, so I was not able to speak in the earlier sessions.
No worries, ma'am. No worries. We'll be moving forward. Trapti, are you ready?
Yes, ma'am.
All right. Just a second. You can present your screen now.
Okay, so am I audible now?
Yes, you are audible. There's a background noise. No, sorry.
So is my screen visible?
Yes, your screen is visible. Please put it in presentation mode.
Okay, so is the presentation mode visible?
No, not yet.
Okay, I'll
Just do it from the bottom bar.
Is it visible now?
Yes, it's visible. You may start.
Okay. So good afternoon. Good afternoon to all the panel members and fellow participants. I am Trupti Gunjar from Pimpri-Chinchwad College of Engineering, India. Today, I am presenting on the topic Analysis of Technological Developments in Airport Baggage Handling System review. So this is a collaborative study conducted by me and my fellow authors. Now, moving forward, I'll be speaking about the problem statement firstly. So baggage mishandling is a growing concern, and it has remained a concern from ages. Although we have been developing in 2025 to the technological developments, and this issue still remains a significant global challenge to the aviation industry. Now, according to the CETA industry and the 2022 and 2023 reports that the research we have done, the global rate reached up to 7.6 mishandled baggage per thousand bags, and there has been an increase of 74.7% in after 2021. So the delay and mishandling of the baggage is increased by 42% in 2023. Now, CETA is the agency which every year gives its report for baggage mishandling, and for entire world report it gives. Now, speaking about what all can be the primary causes for this, human error. So there are chances of 24% of the mishandled baggage are due to human error, due to mishandling during the conveyor belt, during the transport of the bags from one part to another part, that way. Then the outdated infrastructure limitations that are present at the airport. Then security and regulatory inconsistencies, and system in interpret, that is the issues with the system or during the communication from maybe source to destination and vice versa. Yeah, this we have shown the chart which we have got through references from the CETA agency itself. Now, technological innovations, and now what we have tried to do is we have tried to see the trend, what all technologies have been evolved from the 19th century till date, and how these technologies affect the baggage handling and the baggage traversal from source to destination. The evolution of this baggage handling has been noteworthy, I must say. From manual sorting in early days, we moved to barcode based tracking, then to RFID, then to IoT, and now currently we are into there is a mixture of IoT, and there is upcoming AI and blockchain technologies, but there is no such significant work till now in this. Now, speaking about the IoT based systems, there in the current date there are been systems being developed for IoT based after RFID in early 2000. After RFID, IoT came up, and there are been systems for real time location tracking and street tracking, RFID and NFC tags that offer us more than 90% scanning accuracy. Then GPS and GSM module, which updates the location and tracking across the regions. And the upcoming technology involves AI and computer vision technology for automated damage detection through camera technologies, or and by making use of CV models. So this is the technological trend which we observed till year wise. Next, speaking about the comparison, so mainly our review paper focuses on the technological comparison and global adoption of these technologies. So we have plotted a table in which all the technologies are being mentioned and how they affect accuracy wise, cost wise, sustainability, scalability wise, and also their adoption rate. So this we also have tried to mention research review in which the technologies that can be adapted practically in the airport and which are not practically adaptable. So speaking about the best technology till date which we observed was IoT, because the accuracy rate was high comparatively, and GPS and GSM is involved only for location tracking. But if we want both location tracking and baggage damage detection, so IoT proved good, best I can say till date, because the scalability is also high and the accuracy is also high. For AI and CV, the accuracy can be high, but uh, there are restrictions related to the material which is present inside the baggage. IoT can detect that as well if there is no structural damage to the bag, but if there is a damage to the inside components, IoT can detect that, but AI fails there sometimes. Now we have also gone through the real world scenarios about how Heathrow and Hong Kong airports successfully use RFID till date. Then there are blockchain technologies also used for in Air France KLM, but these are mainly for communication purposes. And Dubai International Airport has also implemented CV technologies for baggage processings. It does not include any damage detection part, but the processing part happens through AI. Then now speaking about the advanced technologies which we have gone through, for damage detection, techniques like photogrammetry and 3D modeling are available. So research has been done in this area where checkbox systems and heat maps have been developed, and these provide a more accurate than visual inspection or manual inspection. The heat map authentication is more reliable, but it is only for it is not matchable with the airport norms, I can say. In terms of then there have been research done in terms of threat detection. AI models such as YOLO and SSD are applied to X-ray imagery, achieving a 85 to 95% detection accuracy. Then we also have tried to incorporate passenger-centric solution. Now, what are these passenger-centric solutions? These are solutions which are beneficial to passengers in a way where the compensation, if there is any damage, or if there is any lost luggage, or in that cases the compensation becomes easy, the process for compensation becomes easy. Secondly, the wait time for at the conveyor belts also becomes is also should be reduced. So that way, mobile apps with live baggage tracking can be made available to the passenger. AI for automated claims and integration with airport services can also be made. Now, what all challenges we faced in this research? Aging infrastructure. Firstly, I'll talk about the challenges we saw for the infrastructure related. There are many airports or places where the aged infrastructure, or the infrastructure which are not in use, or even there are manual inspections also available in some of the places. Then there has been inconsistent global standards and compatibility issues. Then there can be issues related to AI and tech adoption issues, which can be there are specific airports norms related to security and related to the concerns with the passengers personal, if there are some personal belongings, so there can be concerns related to that as well. So that also challenge the technologies can be faced. And speaking about there can also be some psychological impact on the passengers. Next, I'll move forward for the future research directions. So what all we have suggested in our review, that these technologies can be noteworthy for research in upcoming eras. So hybrid tracking technology, which makes a combination of two to three technologies together, that can be barcode, RFID, and Bluetooth for universal compatibility. Now these can
This is a gentle 1 minute reminder.
These can be this can be useful. This can be increase compatibility, and also the threat for both damage and location can be decreased. And then speaking about AI, so this will be useful, but there has to be an incorporation of IoT if you want both structural as well as the inside material security. And yeah, so all these we have suggested in our review paper. Now, how we conducted the review: we followed the Prisma guidelines, where we searched databases and registers available at various databases like Springer, then ResearchGate, then most of the databases which are available, and Google Scholar. So that way, and then we screened the papers. Firstly, we selected about 35 papers, and also then we screened based on keywords, based on the criteria that we followed was only for location tracking and damage detection. That is how baggage handling is done at the airport. If there are papers related to security and threat detection, we try to avoid them, because we try to focus on whatever our problem statement is. And then we finally included 25 research papers.
I'm sorry to interrupt, ma'am. Can you just conclude the presentation? You have already crossed the 10 minutes mark.
Yeah. So the conclusion, I would like to conclude through saying that baggage handling can be, has evolved from manual handling to currently AI and CV related changes, but there still exists a huge loophole in the technologies, and there has been research work going, and we have suggested various things in our review paper as well, which include future guidelines and uh, tr- uh, incorporation of 2 to 3 technologies together, which will be helpful for passengers as well as airlines. Yeah, that's it. Thank you.
Thank you so much. Are there any questions?
Yeah.
Yes, sir.
Yes, you told that there are certain regulations in airport, right?
Yes.
How do they accept your research work for implementing these things in the?
So our it's actually not a research work. Actually, we are going. There's another problem statement where we are doing research work, but we are also focusing on IoT related changes. And this is only a review work which we are presenting, which compares all the technological developments that have been done. And airport, like, there is no official database available of airport, but as I said, there are companies like agencies like CETA and
Yes.
ICTIS, so which provides databases and what all work has been gone till now. So that all we have accessed.
Okay. Okay. Thank you.
Thank you, sir. Any more questions? If there are no more questions, we will be moving forward. Is anyone left for the presentation?
Ma'am, yes, ma'am. My team is left.
All right, so you can present now. Can you share your screen?
Yes, ma'am.
Yes, it's visible.
Is it visible now, ma'am?
Yes, you may start.
Yes, ma'am. Good afternoon, I'm Sherlyn, and today I'll be presenting our work on advancing OFDM systems with deep learning and shoe decomposition. This project was done under the guidance of Dr. T. Deepa, along with my co-authors Ashida Prakash and Advait Verma. So, giving a brief introduction to our topic, OFDM is something that is essential in modern wireless communication systems because it efficiently transmits high speed data by dividing it across multiple orthogonal subcarriers, which in return it minimizes the interference, and then it just maximizes the spectral efficiency, which ultimately that is what we're trying to achieve in all the communication systems. It is OFDM systems have been highly resilient to multipath fading and its intersymbol interferences, making it very ideal for like real world wireless environments. That the modern wireless environments, OFDM is like very useful for like 5G and beyond communication systems. So the motivation behind the project was it stems from a critical role that OFDM plays in modern wireless communication systems, But however, OFDM systems are very vulnerable to intersymbol interferences. In return, it will lead to high bit error rates, especially in multipath environments. So what we try to incorporate into this is we tried traditional decomposition signal processing techniques such as lower upper technique or singular value decomposition techniques. What happened is it often lacks the computational efficiency or the numerical stability that is required for like real-time systems. So that is where our method shoe decomposition comes in, offering both better stability and the reduced complexity. On top of this, we are trying to use deep learning methods, especially the convolutional network, offering a powerful tool to adaptively learn and optimize our channel estimation. So, why are we using channel estimation? Is that whenever a signal is given through the transmitter, it doesn't come out like that at the receiver. Even though when we're using OFDM systems or we're using multiple decomposition methods, still it is very prone to interference or like phase differences or any other noise. So in order to like recover the signal that we have given in the transmitter, to recover it with less redundancies, we are using deep learning so that it can adaptively channel estimate the system, and then we can easily recover the signal effectively. So these are the research that we did on the various topics. So one such research here, we're just seeing how machine learning ecosystem can be used in OFDM systems, and similarly, like how it can be used in like real time impairments and all. And to demonstrate like how machine learning techniques can effectively tackle channel estimation challenges in dynamic wireless environments, we understood that from all this research work. So as I mentioned it earlier, OFDM is very susceptible and vulnerable to intersymbol interferences and bit error rates. So we tried to estimate the channel by using traditional techniques like LS and MMSE, which often struggle with rapidly changing wireless environments, leading to less ideal performances. So that is when we obtained the data set and we applied a CNN based ML model for channel estimation, aiming to reduce the bit error rate. So the objectives are core objectives were enhancing the OFDM performance by reducing intersymbol and intercarrier interferences, and then applying shoe decomposition for numerically stable and efficient signal processing. And then we used deep learning, particularly CNN, for real-time adaptive channel estimation. And later we developed a joint channel estimation framework for combining the strength of both these approaches. And finally, we evaluated the performance through bit error rate versus SNR comparisons with traditional models like MSC and MMSC and LSC. So why did we choose CNN instead of the other linear regression or DNN model? Is that we tried several approaches, as I said, linear regression and deep neural networks and CNN. Linear regression was too simplistic and it barely reached like 10% of accuracy. And then later we tried the one drawback we have in the project is that we were not able to obtain more data set. So we were left with only like some 9,600 data set, which we converted into spectrogram images, and that is what we fed inside as the input. And then it was not able to read through spatial patterns as I mentioned earlier. And then we tried using DNN, but when we're using DNN, because of the low data sets, we were seeing underfitting in the cases, and we were not able to achieve anything more than like 30% or more. And then we tried CNN on the other hand, which was designed to capture the local features and all. And it they capture the spatial dependencies in a signal data effectively, so allowing us to reach very closer to 70% accuracy. And here, as you can see, we can see that the training accuracy or the validation accuracy in the DNN model, it was very stagnant around 17%. The validation loss was very flat, which just shows that it is like ineffective learning or like there is a data imbalance. But when we're using CNN model, we can see that the training, it reached a perfect accuracy, but the testing was not so. We are trying to improve the accuracy furthermore by applying data augmentation or like L2 regularization, or like you to use dropout layers to randomly deactivate neurons during training, or to use like fewer layers and all. This is just a pipeline of the project that we would like to show, where to give an idea where the shoe decomposition is coming. Earlier in the other research that we have gone through, it is very common that they are using machine learning for adaptive channel estimation. That is a method that has already been done and widely been researched about. But our novelty in the project is to incorporate shoe decomposition. A mathematical technique is included into the pipeline in order to make the system more robust. So this is the workflow of the project. First, we are getting the symbol generated, and then we are training it using CNN. And then it is converted into spectrogram images. Then we are loading it as an input. Then channel estimation is done using JCS and CNN deep learning model. And then finally, we are evaluating the performance. So this is our novel algorithm that we have proposed. Uh, so these are just the explanation of the algorithm line by line that we have mentioned it here. So as you can see, this is one of our key results that is showing the difference with and without using the shoe decomposition. So as you can see, when we are using the Hartley encoding, Hartley transform is the transform that we are using in shoe decomposition. Generally, we use FFT or IFFT, but then when we are using shoe decomposition, it uses something called as Hartley transform. So when we're using that, we can see at 12.5 dB, the bit error rate is nearly 10 point minus 4, whereas in the traditional system, it lags around 10 power minus 2. So as I mentioned, when we're using channel estimation, again, we can compare the traditional methods, LS and MMSE, and we can see overall MMSE is more effective for the noise suppression and error detection. So this is a final and one of our key results in the project. We compare a traditional OFDM system using FFT and IFFT with one that uses a Hartley transform that is combined with shoe decomposition. So as you can see, at 10 dB SNR, a shoe based system achieves a bit error rate of 10 power minus 4 compared to a 10 power minus 2 with FFT. And at 15 dB, we are able to push it to around 10 power minus 6, which is a very good improvement in these cases. These are the realistic constraints that we were facing. One was the data collection and training posed additional challenges because we were only able to obtain a fewer data sets, which we are trying to overcome in the future of the project. So as we can see, we also compare the two traditional estimation methods, that is the LS and MMSE. The MMSE consistently shows a lower bit error rate across all SNR levels, especially as after 15 dB, the gap widens. This just reaffirms the need for like a smarter and adaptive solution, which deep learning helped us to achieve. Uh, Here to sum up this project, the project just proposes an innovative hybrid model that is using shoe decomposition for signal stability and CNN for adaptive channel estimation. Together, they reduce the bit error rates, improving the spectral efficiency, requiring fewer pilots, making the system ideal for real-time SDR and future 5G applications. So compared to traditional techniques, we show consistent improvements across multiple metrics like bit error rate and SNR. And in the future, our next step involve testing this across real-time SDR hardware such as Adam, Pluto, and etc., and optimizing the model for low latency environments. Thank you.
Thank you so much, Sherwin. Are there any questions?
No questions.
All right, thank you, sir. I think Prashant is here. Prashant,
Yes,
are you
yes.
available?
Am I audible?
Yes, you're audible. Do you want to present?
Yeah.
Okay, please share your screen.
Is it visible?
Yes, it's visible.
Okay.
Please put it in presentation mode.
Yeah. Thank you, ma'am. I'm Prashant Raut, and I'm a research scholar from Kashibai Nauli College of Engineering, Pune. And my topic is hybrid deep learning framework for retinal disorders classification using VIT, efficient net, and ResNet 50 with risk grading. And this particular research is conducted under the guidance of Dr. Sachin Babar. This is the agenda of my presentation. I will like to discuss about the severity of this research, why this particular research is required. One of the important sensory organs of the human being is eye, that we all know. However, many people are suffering from visual impairment globally. According to the World Health Organization's report in 2019, 2.2 billion people are suffering from vision impairments or blindness. In the given graph, you can see the prevalent reason for the visual impairment is the unaddressed or refractive errors, then followed by cataract, glaucoma, corneal opacities, diabetic retinopathy, and trachoma. So these reasons impacts very huge burden on the eye diseases, like physical health, the mental health, cognitive development of the patients, then employment and economic opportunities, and lack of ability to the technology. Many practices are being conducted to address all these impacts, but there are some limitations, like limited early detection capability, subjective and inter-observer variability, then time consuming. If current practices are time consuming, then low doctor to patient ratio, limited accessibility to specialized services. These are the various limitations of the practices that are being currently used. That's why the this particular research is being carried out, and for this to address the mentioned problems, the imaging modalities that are used are color fundus images. The color fundus images are nothing but the posterior part of the eye, which includes the retina, then optic disc, and blood vessels, and which is non-invasive. The limitations are which we found in the literature are limited data availability, then lack of consideration of global spatial relationship, then multimodal input pool, imbalanced data set, diversity of the data set. So the research aims to design an efficient and reliable algorithm for classification of ophthalmic diseases, which includes diabetes, cataract, glaucoma, AMD, hypertension, myopia, and which are normal, using the color fundus images and computer color. We are using color fundus images particularly because which are widely used in our nation, in India. Computing learning methods which will also precisely estimate risk grades of the classification with limited data set. So the objectives are to analyze the gap in the literature, then to propose the algorithm, then to test the proposed algorithm, then to evaluate the performance, and finally estimate the risk grades. So the methodology that we have used for this particular research includes three pipelines: fusion, risk grading, and training. Here, this is the data set that we have used: ocular disease, intelligent recognition 5,000 dataset that we have collected from China, and it was issued in 2019 for Grand Challenge, International Grand Challenge. And you can see here the various types of eye diseases, and for which we have used the number of images for training and testing purpose. This is the proposed methodology: Vision Transformer branch, then Efficient Net branch, and ResNet 50 branch. All these three branches are capturing the, extracting the features from the input images, and these images, these features will be fused, and which will be handed over to the softmax classifier, which will, after classifying the images based upon the probability of the disease, the risk grading is done, and finally the risk grading is provided us in the form of low, moderate, or high. This is the accuracy of this model. Proposed framework outperforms the state of the art, that is 97.8%. These are the graphs. So for the risk grading, the proposed framework again, the MAE, mean error square, is 0.12, mean absolute error, sorry, 0.12, and Cohen's kappa is 0.89. So again, it outperforms the state of the art. And in conclusion, with an accuracy of 97.8 and AAC ROC curve 0.98, mean absolute error is again 0.12. The proposed algorithm outperforms the state of the art. These are the references. Thank you.
Thank you, Prashant. Are there any questions?
No questions, ma'am.
Right. Thank you so much. With that, we come to an end this session. I sincerely thank all our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We'll be happy to have you in the 10th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to this printer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I also thank our session chairs, Dr. K. Selvamani and Dr. Archana Chaudhary, for chairing this session. Here is a small token of appreciation on behalf of the team of ICTIS as well as GR Scholastic. With this, I conclude this session. I request you all to kindly open your camera so that we can take a quick snapshot of the session. Right. 1, 2, 3. Thank you so much, everyone. Thank you for your presence.